Alright, so here's this problem again, guys. One other thing we need to talk about. It's this question right down here. Find the area under the curve for the first 5 seconds. And that's kind of a loaded question. So if I were just to give this to you, I'd get a lot of people who wouldn't do it. They'd say, I don't understand what this means. What does area under the curve mean? Where's the curve? So here's the deal. This is your curve right here. This line, this straight flat line is your curve. That's the curve. And that confuses people. They're like, that ain't a curve, Sharky. I'm like, well, yeah, it is. That's your curve. Why is that the curve? Well, here's what happens. If you take any curved line, wavy line, whatever you've got, and you zoom in, and just keep zooming, and you keep zooming, and you keep zooming. Eventually, any curved line is going to look straight. So, this is our curve. Okay. And they want to find the area under that curve for the first 5 seconds. What the heck does that mean? So here's what this means. Find a different color. Here's 5 seconds right here, right? So I'm going to do exactly that. I'm going to take my pencil and I'm just going to draw a line up to where the curve is for the first 5 seconds. The area, I mean, we're just doing exactly what it says. We're going to find the area of this shape, this area right here. And this is very easy to do because this is a rectangle. And so you guys ought to be able to tell me what the area of a rectangle is. The area is length times width of a rectangle, or square, whatever you want to call this shape. Okay? So we just do that. So people do this, you know, they kind of still look at me funny and they're like, what do you mean? I'm like, well, this is the length here. What is it? It's 5. So we'll put 5 in for length. What's the height here, or the width, or whatever you want to call it? It's 20. It goes from 0 to 20. This distance right here signifies 20. And so we put 5 and 20. And here's what folks do. And so they do this. They go 5 times 20. It's 100. I'm like, great. Okay, that's the area under the curve. But what does that mean? You know, and you're going to be annoyed with me when I ask questions like this. What does it mean, right? What do we really do? What is this? This isn't just 5. It has a meaning. It's seconds, right? Because it's the time. So this is really 5 seconds times. This up and down is 20 meters per second. And that equals 100 something. And I'm fascinated by this. This is AP Physics. You know, you guys are mostly juniors. There's some sophomores, and I have some freshmen. And I'm always fascinated when I ask a question, what happens when you take 5 seconds and multiply by 20 meters per second? I get all kinds of neat little answers. So what is it? Well, when I take seconds and multiply by meters per, ignore these numbers. When I take seconds and multiply by meters per second, right? So here's meters per second. I'll put that in parentheses. Here are my parentheses. There you go. Seconds is really seconds divided by 1. Seconds is in the numerator. Meters is in the numerator, and then seconds is in the denominator. And what happens is the seconds cancel. I have a seconds up here at the top, on top of my line. I have seconds on the bottom. The seconds cancels. And I'm left with meters, right? So this 100 here is 100 meters. So that 100 meters is the area under the curve. So it's a displacement. What does the area under the curve here mean? Well, we took a length of time and multiplied by a width of velocity. Velocity times time gives you displacement. This is an equation. The equation is velocity equals distance divided by time. That's actually what you're doing. Okay. And so when you do velocity times time, what you're doing is you're taking this equation right here and you're moving things around and you're solving for d. So when you solve for d, what do you get? Well, you get this. You get d equals v times t. This is just math. That's what we did here. We took v and multiplied by t, and we got a displacement. Okay? That's what happens when you take the area under the curve of this graph. So here comes a fact. Fact. Area under the curve of a velocity time graph is the displacement. This is how far the car went after 5 seconds. And if you look at the first video, right, when we did that first graph, you'll see that at 5 seconds the car went 100 meters. Okay. Well, here's another graph. There's a little typo here I got to fix. Right. Oh, no, there's not. Just kidding. So here's a graph. Sorry. And you've got a bunch of lines. And there's some questions that you have to answer. They tell you it's a displacement time graph, so displacement and time. Okay? Can you answer all these questions? So here's the answer to the first one. How far does the object travel during the first 5 seconds? Well, during the first 5 seconds, it travels 5 meters. See that it's at 0, right? And in 5 seconds, right, which is right here, you can look over to the y-axis and see, all right, it went from 0 to 5 meters. All right, how far does it travel during the second 5 seconds? So from this time to that time. All right, so during the second 5 seconds, it doesn't travel at all. At 5 seconds, it's at 5 meters. And at 6 seconds, it's at 5 meters. And here's 7 seconds, it's at 5 meters. Here's 8 seconds, it's at 5 meters. So you see that flat line there should tell you something. Okay? This is something to know, that when you see a flat line in a displacement time graph, it means something. In this case, you're not moving. All right, what about these three? Can you do those? Next one. You start at 5 here, you end up at 15. So if you end up at 15, you started at 5, the displacement is 15 minus 5, which is 10. Here's the next one. How far do you go from 15 seconds to 20 seconds? Another flat line. You're stuck at 15 meters. You're not moving. There you go. Here's this next one. How far does the object travel during the last 10 seconds? Well, it starts at 15. It ends up at 0. So there's two answers I usually accept here. I accept either 15 meters or negative 15. The difference here being the minus or plus sign. Negative and positive mean direction. This is asking how far, so really, it's not really asking displacement per se. So either one of these will work. This is a loaded question, this very last one here at the bottom. During which time interval is the object standing still? So between what times? Hopefully you know that, well, it's between 5 and 10, 15 and 20. That's a thing. Okay? All right, last practice. Take a look at this graph. It looks like it's the same graph, or a very similar graph. It's got some of the same lines on it. Okay? What type of graph is it? You need to be able to look at a graph and go, what kind of graph is this? Can you answer some of these questions? So this is a velocity time graph, which means we're graphing velocity. Okay? So this is different than a displacement time graph. Time is the same on the x-axis, but this is velocity. Okay? So let's take a look at this question right here. During which interval during which time interval is the object standing still? And what people will tell me for this one right here is that they'll say that it's standing still at this between 10 and 15 seconds. They'll say between those two times. It is not moving. And that's incorrect. That would be correct if this were a distance time graph, but it's not. This is a different graph. This is a velocity time graph. So what's going on between here and here? Well, you have a flat line. You're like, Sharky, you said when you have a flat line, that means nothing's moving. I did. I said that for a distance time graph, right? This is a velocity time graph. So this flat line means that your velocity the whole time is 15. So during which interval does the thing have the same speed, have a constant speed? This is not very well written. It would be this interval right here, that it has a constant speed. Okay? At each second here, the speed is 15 meters per second. Now, during which times is this thing accelerating? I guess we need to know what that means. To accelerate means what? All right, let's go back to our facts here. Fact, the slope of a velocity time graph is acceleration. To accelerate, we haven't really talked about this yet. We're getting ahead of ourselves. To accelerate basically means to have a change in velocity. So if you look at this, here our velocity is 0. Here our velocity is 5. So we have a change in velocity between here and here. Right? So we could put A there, because it speeds up. In 5 seconds, it goes from a speed of 0 to a speed of 5. So it accelerated. Same thing here, from 5 seconds to 15, right? Your speed went from 5 meters per second to 15 meters per second. So it accelerated in part B. Part C, it was cruising. Speed was constant at 15 the whole way from 10 to 15 seconds. It's not speeding up or slowing down. How about here, from here to here? Did the speed change? Yeah. How about from here to here? Did the speed change? And the answer is yes. Okay. Question, could you find the slopes of all these little line segments? I hope so. You need to be able to do this. Slope is rise over run. So for line A here, the rise is 5. The run is 5, right? 5 divided by 5 is 1 meter per second per second. So the acceleration here is 1 meter per second per second. Can you find these other slopes? Give it a go. So there are all the slopes. Last question here. What is the displacement during interval A? So how far did the car go between 0 and 5 seconds? How do we figure this out? Well, remember we talked about the fact that the area under the curve means something. Okay? What does the area under the curve of a velocity time graph mean? It means displacement. So can you figure out how far the car went from here to 5 seconds? Well, you'd have to find the area under this curve right here. Look, this is something you can do because that shape is a triangle. Can you find the area of a triangle? You should be able to. A little tougher question. Can you figure out the area from 5 seconds to 10 seconds? That's how far did the car go from here to here. This seems to be a weird shape. Could you break it up into two little more comforting shapes? What about a rectangle and a triangle? Add them up.